Hello, you beautiful people. Another episode of UncleCode Review with Sham and Shahari. I gave the names. Hello, Ash and Maysam.
Hello.
Hello. Hi, UncleCode. Hi, Mason.
All right.
Very good. Perfect.
Good afternoon. Yeah.
Can't wait to start and go to our today's students code. So, Ash, let us start. Who is the first?
All right. So, just to give a little bit more background between these two kids, they're actually brothers. So Sham and Shahari are brothers.
Yeah, brothers. Nice, nice. You guys gonna set up a company, tech company. Nice.
Yeah, and they joined back in 2019. So I guess we can start with the eldest. Sham is the eldest. He joined. So both of them joined in 2019, and now he is 14.
Now he's 40 years old.
Yes.
Sham. Fantastic, Sham. Okay, I remember you.
And this is Shahari.
Shahari. Okay, both of them. So
Yes.
2 years difference between them, huh? One is 12 years
Yes,
old now.
2 years.
Okay, Shahari, 12 years old, and Sham, 14. Which one we're going to start? Sham or Shahari?
We go with Sham, the eldest
Okay.
one.
So the first one is a Sham, huh? Is this code for Sham? The Q?
Yes.
Yes.
Yeah.
Okay, so I'm going to run it, Maysam. Any comments for the code?
Some of the codes are for drawing the alphabets. Somehow like writing the letters from different letters. This time is the time for Q. All right.
So, Sham, you draw a letter Q. I think you draw other letters as well. But this one is interesting because it has 4 colors in it, or 5 colors. It means like in every movement you've done something new. So that makes it a little bit tricky. You started with the yellow and the green and the red and the orange and the blue. You know, when I look at the code of you, Sham, look at your guys that he started with going to right but minus 90. That's interesting.
Nice.
So technically you can just say left 90 because that's what it does, huh? The point in the negative numbers change the direction of the rotation. So go left minus 90 degree means go right 90 degree. Or go right minus 90 degree means go left to the 90 degree. So, but I like the way you thought of it because it's actually a little bit more complicated. But you if you think like that, this shows some interesting a symbol of sort of kind of intelligence that we needed in some sort of calculation, designing, kind of logical, like a kind of the
Or
negate.
some sort of show off. Oh, I know how to do it.
I know how to do it. negation of x is like x, you know, or minus 2 is 2, you know, something like that. So right minus 90 is left 90. So you can just switch it. But one of the things is, of course, when you work with some other programmers, it's good that you make your code readable or a little bit explicit for them that they understand it. So now here you went to 200 because you went to the left 90 degree and you draw this line, and then you did change the color green, and then right 90, and then 100, then 90, then red 200. Bravo, very good. And then the 90, and then you come and draw this 100, then you backward here, and then you left 180 minus 45. That's nice. I like that you didn't write 135. You let the Python does the job. Okay, so 180 minus, because you want to come here and the Q is like 45 degree. So it's a right angle, triangle. So that's just interesting things. And then backward 20 and forward 20. So, you know what, when it comes to coding, when we finish our code and when we run it and we see it, it's good to do evaluation. We call it evaluation after correctness and evaluation. So an evaluation has different principles, you know. So one of the things that we do under evaluation is if I can do this with lesser line of code or faster, you know, that kind of things. If there is any repetitive patterns that I can turn into a kind of for loops or not. If I have done enough decomposition of the main problem or my solution looks complicated. So a lot of things that we can do that. So here, if I want to just evaluate or your solution, for example, I may gonna come up with some idea that what if I can do or how can I write the code to make it maybe smaller and shorter. One idea is, what if instead of I start from here, I start from here. That means I start from the top right corner of the cube. Okay, it starts from this. So what's gonna happen, because I'm gonna go one roundabout and then finish. But in your case, now you do this. Okay, you know what you do. You come here, you come and you have that backward. So I can eliminate that backward. That's one way to do that, right, guys? So we can do that. And then so I'm just imagine. Let's go through your code, Sham. I'll go to the left, for example. For now, I'll just follow your code, okay? And then I go for, I assume that I'm starting from here, okay? Let's say I'm starting from here. So I go right, left, 200, and then I will just go another left, 90, and then I go 100, another left. And you see that now everything back to the left, because I can do a one circle. And then forward, and then the left, and then forward. So now I don't need the backward. I don't need the backward. So I'm just in the position, and I can just go to the left, or because I'm there, I want to go to the right maybe a little bit this time. Okay, so I'll go to the right 45 degree. You see lesser calculation, and then backward 20 and forward 40, for example. Or maybe I can just stay in the middle, if unless they ask me to just go to that point. So if I'm going to run this, okay, I got it kind of. Oh no, that 40 was correct. So now I got a Q. So I got a Q. But of course, if you want to change the color order any way you want it. But this is easier, faster. Imagine you're building a game that within the game, game creatures they looks like a queue, and there are 10,000s of them. Like Clash of Clans. Look at all of them are just jumping out of the game. So imagine this queue is that game spread, that game picture. So 10,000, no, maybe 100,000, sometimes 1 million of them you have to draw it. That even one little line of code make the game much faster and smoother, and gamers and your users, they love your game and they play more. So that's what I can say here. You can also play around a little bit with the for loops, but I prefer to not talk about it here. You can do that. One of the things that you have to figure out what pattern is repeating here. Going 200 and turning right, and then 100 and turn right is what is repeating here. So going 200 and 10 left, and then turn left. So that's the pattern is repeating here. But there's another thing that you keep changing the color here. So if you want to do that, you have to create a list of tuples. I think it's gonna be a little bit messy. So, but for this code review. So my main point is how you can, reduce a little bit the code and make it faster in this way. But what if we forget about colors, huh? For a while. Okay. And then let's see what will happen if we so let's see what's gonna happen. So you see, by the way, try to learn short keys and that make you faster in coding. So then I'll come here. I want to see that I have a left 90, forward 200, left 90, forward 100. Let's see if I can give anything out of this, and then 200 and 100. So you see that I found a pattern. I found a pattern that is repeating 2 times. So now if I can, wow, now all the letters yelling at me. So for count in like a range 2. So what I'm gonna do that I will just remove this stuff. So you know what? Now I'm trying to simplify the problem. This is called relaxation, or reducing problem to something smaller than that. That means I forget about the colors. Why should I think of the colors now? I will think of them later. So now let's see if I can come up with the for loops. So then here I don't have these little things here, so that just right in the back or forward. So then, so now I'm going to think of a little bit of colors. So let's see if I can bring colors. But there are 2 things that I have to do. I have one point here. I have to change the color here, right? And I have to change the color here as well. So I have 2 points to change the color. Well, so I know that I have to do something with functions. I mean, the way to do that is just write Tom colors. So
what if we make it using a module and remove 2 more lines and would use a multiplier for instead of 100 and 200 for the let's say for even numbers for module 2, and we add another 100 to go forward. For the counts, for example count 0, we need to go 200. For count 1, we need to go only 100.
So you want to tell me to remove what?
Let's say instead of forward 200, it's a forward 200 minus count mod 2 times 100. It's a little bit, yeah.
So you want to parameterize the number, huh? Here.
Yeah.
Okay. Okay.
It,
Okay. We can try to do those kind of things also. But slowly, step by step. We add more abstraction complexity to that. That is good. So now here I'm thinking of the colors. So what we're saying about colors. So we're trying to see that if we can bring colors into this reputation or not. And then let's say I do have, because I can see that you use really different colors. You keep using different colors. So that makes it a little bit difficult. But what I do is this. Two ways. One way is I create a list of colors here. And I make the light green, because I see that what you have done, you just use these colors back to back. So that means I can just assume that no matter where I am in this rectangle, the first color is going to be light green, the second color is going to be red, the third is going to be orange, and dark blue. Because I guess the list, you've been here for a long time, so why not to do that? So what I do, I use index. I use a variable to tell me where I am in a list. So I call it color ix, or index is 0. So 0 means I'm referring to light green. When it became 1 means I'm referring to red. When it became 2, I'm referring to orange. When it's dark, so what I have to do is, in proper position, I play around with the color index. That's what I have to do, huh? So for example, let's say if here I write that colors and color index. So what it does, it changed the color to light green before doing the forward. Then again here, I'll come and I'll do the same thing, but now color index should change. So I'll increase the color index. So now I pick up the 0, light green, and then gonna be 1, and then it will be red. Then the next 4 loops, okay, so let me start from this to make it easier. And also I have to increase it for the next cycle. For the next cycle, then I'm going to do that. So what I do, I start from a -1. I think I like this one to be better like this. So now better. So now let me run it. Oh, we need more colors, right? What he did for the last colors? It was one more colors I think he used. Oh, yellow. He started from yellow. Oh, I got it. Yellow. And then he used the blue for just a little part of the cube. So this one is out of the loop, so we're going to do it. Okay, so here, well, it's this kind of indexing is very important, very common in coding. So I start from the -1. So what I do, -1 + 1 is 0. So I pick up the 0 colors, which is yellow, and then I increase it, and I will go and I pick up the light green. And then in the next cycle, color X is 2, it becomes 2, and then I get the red, and become the 3. I got the orange. This is nice if you want to do something like that, which the pattern, we call it emerged pattern. The pattern is not atomic, it's not single pattern like when you draw a square. This is rectangle, which is a mix of 2 other things, and something is flipping. So that's a common way to do that. But it's still, you're referring to the same atoms. So it became a little bit complicated here. So, but anyway, well down. But you can see that how one, again, like many other times that I always say that, how one task can be really a source of a lot of skills for you. So all your students, Sham and Shahari and any other students, do not just answer one task at Kidocode. Try to play around with it. Try to evaluate it. This is good.
Very important.
And sometimes ask your friend to come and do that. It's very important. What do you think? How can I make my code better? Let me also tell you how can I make your code better. So this kind of conversation eventually makes you knowledgeable and stronger. So let's go for the next student.
Nice. So now we're gonna go for Shahari, his younger brother.
Oh, younger brother. So
yes, this is Shahari.
Perfect.
Yeah.
Any point made some for this code?
Nothing so much. Nice use of for loop to create a slope of the circles, actually.
Look at that.
Interesting. So how many? 5 circles, and then all moving up like a kind of 45 degrees. If we connect the center of all these circles, I had the feeling that it's 45 degrees.
I believe so, yeah.
It looks like that. Maybe not exactly 45 because it's coming here. Should come here maybe.
Yeah, it's 45 degree. Yeah, it's right and 45. So I think it's the yeah.
If it was supposed to be 45, the circle should come exactly here. It's a bit lesser than 45.
That depends.
If you connect
Let's
the
see.
center to here,
Maybe because of the way that the turtle is drawing the circle, it doesn't. This is shifted a little bit to the left. It doesn't draw it from the center.
no, it doesn't draw from the center. Is right. What I mean is, I was thinking that if we connect center of all these circles, will be a 45 degree, but it's not 45 degree because it come here. If it's going to be maybe the shape is not fully square. Maybe it is 45.
Maybe it
Yeah,
is 45. Line 5,
45.
it turns right 45 degree.
Oh, you started from here. So, Shahari, let's see what we can do for your code. Here, what I like to do first is to see that how we can do some kind of little tweaking over your code to make it a little bit, smaller and maybe faster. Let's see what's gonna happen. First of all, I like to see what will happen if I don't do that. Okay, so you are just going up. So, I mean, just so this is very important. I want to say that forget about that right 45 degree. This is what Turtle's supposed to do. Turtle in his mind drawing 5 circles in a straight line for his. So imagine if you tilt, think about it, Shahari and everyone else. Imagine I'm the turtle. If I close my eyes and you turn a little bit my chair to the other side and I don't know anything about it and ask me go forward, I do the same things that when I am like this, right? Because I have no idea what to do. So turtle doesn't know is moving 45 degree or is going to straight. It's just draw circles behind each other's. So if I know how to draw this, so just by this little magical line, I can tilt it to any direction. So that's what I want to try to say that. Maybe it's nice that you first do this, and then from here, before this, maybe the challenge should be given to you is this. That means draw 5 circles like this. You just draw it.
It is like that.
Like that. Fantastic. Great. Are you able to make it to be 45 degree with just one line of code, which is the solution? Because you understand that turtle is just following. So why not I just position turtle at the beginning this direction, so turtle will draw in that direction. This is actually the space, because when you are in the middle of the space, there is no up, down, left, right. That's what we call it. You know what? Even we say observable universe. It means wherever you stand, around you are the center of the universe. So wherever you are, if any alien, any one of you live anywhere in this universe, you feel you're the center of the universe. Because that's the meaning of infinity. So that means you are the center of that universe. So it's a little bit interesting. So for turtle, it's like that. When you treat turtle like this, it doesn't matter. So that's correct. It's 45 degree. Yes, definitely 45 degree. And then also, I'm gonna go and try to reduce the length to make it like this, and I will give again a little bit of speed. Okay, so now the other thing that I'm going to do is, I'm trying to understand your code. So I want to show how I understand someone else's code. So what I do is I try to ignore the pen up and pen down. It's important for me. So because I can see the trajectory line. Trajectory line is very important in geometrical shape, in computational geometry. That means I can see what is happening. What is going on there, so I can see the line. This is actually the line. So you can do whatever you want around this line, but when you make it pen up and pen down, we don't see it, but it's there, right? And then the other thing that I like to try here is, what if I change this 70, because you're drawing a circle with a radius of 25, so it means that here is 50. Here is 50. Let me make it 1 first. Let's see, 1 pattern. So this is 1 pattern. That means you start the circle here. Just let's do it again, because you did the right 45 degree. So now you're doing this. Technically, you are transforming the space. Nothing changed. Just again, my chair became like this, and still I'm walking straight. So then, what if I go and do this 50? I'm going to end up exactly on border of the circle because 50 pixel, because from here to here is 50, because 25. So you must know this connectivity because it's geometry, it's fixed. So if I'm gonna go and make 5, so I'm gonna have circles connected together, right? So now the question is how much you want to give them a space. So then you will come and write down the epsilon or the delta between these shapes. Let's say I want to make it 10. Okay, or make it minus 10. Okay, you see, engaging them together. So now they have overlap. So, or maybe, or what if I want to bring count into this? So plus count multiple 10. So see what is happening. So what I'm trying to say that each one of these shapes, they can project or simulate something in the real world.
It's now accelerating.
Bravo, bravo, exactly. It's getting like kind of is moving out. So now I will back the pen up and pen down. You know, you feel it. You can feel it exactly. So, or these are the different ways that you can play around with such a kind of concept.
It's nice for animation.
Exactly, it should be. It should be. And then, so what else we're gonna do here is, so the code is nice. Good job. I like the for loops. You can use the go-to as well. You can use go-to. Go-to is important. Go-to requires you to think a little bit about it because you are here and you want to come here. Okay, so if you are here, you want to come here, that means you have to calculate the location of this points or this points or this points, because now when you draw the circle, you just come here, you know, when you draw one circle. So let me again, interesting. So I'll go for one. So look at what is happening here. You go to left 90 when you are here. You go left 90 because and then you go forward 50 and then you go right 90. Okay, it makes sense because you are like 45 degrees, so you have to go 90 and then back to this. So you're not thinking of and of course your original code was 70. But if you want to use go-to means do not use this stuff. Just figure out the x and y here. So you have to calculate how much x is here, how much y is here. Okay, and you know that use hypotenuse theorem. You can understand that how much you're gonna go, or you're gonna pick up.
Just add x and y to that. Yeah.
You use any of them, for example. It depends. For example, if I tell you that go this distance, top and left, so then you have to use hypotenuse theorem because you have to pick up. That means when distance. When you're deciding where to go, then there's another things. So that's another thing that you can do that. For example, here, for example, you're gonna say that Tom, that like go to, for example, let's say I'm just gonna go to like how much I go, for example, the original location is, for example, let's say I'm gonna go 50-50. Okay, I'm just what I did now. Okay, from because you are here already, so I just jump here. If I draw it again here. Oh
my god, it got crazy.
It should be count.
Yeah.
Multiple by this. Let's say count. Multiple by this. So it's something like that. So that means 50, and then again more 50, again another 50, and again another 50. Because go to calculate from the center. Okay, not from the last position. So anyway, one of the approaches, you can go for that and you can have fun with it. But still, I like I like what you did. I mean, that's nice. It's cool.
Nice transformation.
Yes, a lot here. And then okay, that was his main code. Perfect. So that's all. So we talk about how you can simplify a code to understand it. That's a very important thing. And then also we talk about just a little bit of playing around with the distance between them, and also interpreting interpretation of your task for the real world. That's very important, because at the end of the day, if you are chemist, if you are artist, if you are you're writing novel and stories, whatever you do, you have to be able at some point apply it to some real things happening around the world. Then people can understand it. Imagine there's a beautiful formula in mathematics, but I don't know where I'm going to use it. And it happened many times in human science and in human story. That means a mathematician come up with the result, but he didn't know where I'm going to use it. But it's beautiful. I don't know where I'm going to use it. But then 50 years later, another guy picked up that beautiful tools and applied to something else in the real world. And everybody, wow, this is amazing. We can explain gravity with this, with what Isaac Newton did. Or we can explain light with this, or we can explain quantum physics with this. So when you do something like that, you have to figure out these coding skills that I'm learning, where can I apply it? And then when you try to, for example, oh, maybe I'm in charge of simulating how atoms and molecules accelerate, or maybe a game, or maybe I'm a part of the NASA team to do this stuff for them. So then you try to feel better, stronger. Then the magic will come in your brain. So, Sham and Shahari, I have to tell you something very important.
Yeah.
Very important. And that is, you are
Programmers.
programmers.